Welcome back to the last episode in our Chapter 1 lecture series, and our topic for this video is homeostasis. Now, homeostasis literally translates to unchanged and standing, so standing unchanged. And what that's talking about is the balance that has to exist in the inside of the body in order for your chemical reactions and cellular processes to take place at their optimal level. Now, homeostasis, again, is referring to the internal balance. We'll see that there is always this natural set point. The set point is like the textbook average of what that particular setting should be in the body. So maybe it's the internal body temperature set to 98.6 degrees Fahrenheit if it's the textbook average, or maybe it's talking about your blood pressure or your heart rate or your calcium ion levels or your sodium or potassium ion levels or your fluid levels. So whatever environmental condition it is that we're talking about, there's going to be what's called the set point. So that is the optimal level for that particular thing. Now, the reality is that in the body, you're never probably at 98.6 degrees Fahrenheit for long if you ever actually hit exactly that mark. So what we see is that we're really doing a little bit of a fluctuation always around that set point. So maybe we're a little bit too hot, a little bit cooler, a little bit hotter, a little bit cooler, always making these little adjustments. So really you're fine as long as, I imagine, your little wave, your little fluctuation around the mean is pretty small. It's when that fluctuation starts getting really dramatic that you're starting to feel bad and maybe need some outside intervention from a physician or something along those lines. Now, homeostasis in the body is regulated using two different mechanisms. We have what's called a positive feedback mechanism and a negative feedback mechanism. So let's talk first about what positive feedback is referring to. In the case of positive feedback mechanism, the term positive here doesn't mean like good, excellent, yay. It just means going the same direction as the stimulus. So you're going along at your set point and it becomes elevated for whatever reason. And so instead of automatically returning to normal, you're going to see with positive feedback mechanism that you're going to keep going that same direction. Keep going, keep going, keep going until, I think this needs to be over here, keep going, keep going, keep going until ultimately you get back into your set point. So positive feedback mechanism is the same direction as the stimulus. You're moving away from homeostasis before finally returning. So it's kind of like this picture. It's like a snowball effect. More, 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 more. Okay. All right. So examples of when you would see positive feedback mechanism in the body: micturition reflex, which I'm going to give that example here in just a minute. That's your urinary reflex. Defecation reflex is another. Labor and delivery is a classic textbook description of positive feedback mechanism, and so is blood clotting. So you'll often see labor and delivery and blood clotting mechanisms described for you in terms of your positive feedback mechanism. I'm going to show you the micturition reflex. So here I've drawn for you my kidneys, my ureter taking the urine to the bladder storing the urine. So here we see with our micturition reflex that the bladder begins to fill with urine, and this is going to cause pressure to build in the bladder, which is going to lead to a smooth muscle contraction of the bladder. So if you've already got some fluid in there with some pressure and then you squeeze, that's going to increase your pressure. You're going to see that more urine is going to make its way to the bladder, and again, that's going to cause more smooth muscle contraction of the bladder, increasing your pressure. So it's that initial filling up of the bladder with urine causing the muscle contraction to cause that sensation of pressure to get more and more and more and more urgent until micturition occurs. You empty the bladder and you go back to normal. So this is a perfect example of a positive feedback mechanism. Same direction as the stimulus. Urine leads to pressure, which leads to more pressure, which leads to more pressure and more pressure until ultimately you empty the bladder. In the case of a negative feedback mechanism, you're going in the opposite direction as the stimulus. So the reason it's called negative is not because, boo, it's bad. It's because it's the opposite direction. You're negating the response or the stimulus. Okay, classic example here is regulation of body temperature. So in this case, you know, if you're too hot, you're going to cool the body down. If you're too cold, you're going to warm the body. So you're going the opposite direction of the stimulus. Now, this is going to look like a figure 8. So again, if you're too hot, then you're going to do some things in order to bring that temperature back down, cool the body. If you were too good at that and you cooled the body a little bit, you're going to do some stuff to bring the body temperature back up to that set point. So I really like to imagine with these negative feedback mechanisms especially that we're always making these little fine-tune adjustments. Again, probably healthy normal state, I imagine my figure 8s to be very small, and then, you know, if you really are starting to have problems and are getting to the point where you need intervention, then maybe that figure 8 is really large, or maybe you're doing more of one side of the 8 than the other, and so you're not establishing that balance. Lots of examples of negative feedback mechanisms. You'll go through these in a lot of detail, especially in A&P2. So blood pressure, respiratory rate, heart rate, calcium ion levels, which we'll talk about this semester, and sodium ion levels would all be regulated in a negative feedback mechanism. So here is an example from blood pressure. So in the case of blood pressure, if your blood pressure is, you know, too high, then you're going to take some actions to reduce the blood pressure. If you're super effective at that and the blood pressure is too low, then you're going to do some actions in order to increase your blood pressure. So again, the key phrase here is negate the stimulus, opposite direction. Look for that figure 8 in your diagrams. Now, this diagram here, let me grab my book again, is from your textbook. So it's a table. We're not memorizing the table, but really what I wanted you to see here is that homeostasis is the primary physiological process of the body. So we went over our 11 body systems and we talked about the jobs that each of them have. They are all in some way helping to maintain homeostasis for the body. So you can see all body systems are involved in some way or another. Typically, we think about our communicating systems, nervous system and endocrine system, as the primary ones involved in maintaining homeostasis and coordinating these processes. All right, that's it for chapter 1.